Okay, in this particular problem, we're going to use the power, product, and quotient rule to simplify an expression with negative exponents. So we're going to simplify x to the negative 1 divided by z to the third times negative 3, x to the third, y to the second, z to the negative 3 power. And our answer can only contain positive exponents. So first thing we're going to do is make sure to basically distribute this negative 3 exponent to each term in the second set of parentheses. So the first set of parentheses will remain unchanged for the time being. X to the negative 1 over z to the third. Now in the second set of parentheses, we're going to write, or second thing, we're going to write negative 3 to the negative 3 power, x to the third to the negative 3 power, y squared to the negative 3 power, and z to the negative 3 power. All right, now next up, the x to the negative 1 over z to the third. We will leave that alone once again for the time being. Negative 3 doesn't have an exponent, so we assume that the exponent is 1. So what we're going to have is negative 3 to the negative 3 power. X does have an exponent of 3, so first off what we're going to do is multiply the exponents. 3 times negative 3 will get us negative 9. Let's write y. 2 times negative 3 will get us negative 6. Z does not have an exponent just like the negative 3, so we assume that it's a 1, and what we're going to wind up with is z to the negative 3 power. All right, so let's continue here. The x to the negative 1, we'll leave that as it is once again, and z to the third, we'll leave that as it is. If you have a negative exponent, what you can do is make it a positive exponent, but you have to take the reciprocal of the base. So the negative 3 to the third is going to become, the negative will still stay there, it's going to become 1 over 3 to the positive third power. X to the negative 9 is going to become 1 over x to the positive 9 power. Y to the negative 6 is going to become 1 over y to the positive 6 power. And z to the negative 3 is going to become 1 over z to the positive 3 power. Now, we can take this x to the negative 1 here. If you have a negative exponent, like we said, you take the reciprocal. So this x is going to move down to the denominator. So let's write that. If we move it down, I'm going to have a 1, and then x times z to the third. That's what happens to the terms in the first set of parentheses. We have a negative here. 1 over 3 to the third is 27. And we still have the rest of our terms. 1 over x to the ninth, 1 over y to the sixth, and 1 over z to the third. Next up, what we're going to do is group our like terms together, and therefore we have all ones as our numerators, and we have one negative, so we're going to wind up with a negative for our answer, and we're going to have a 1 here as our numerator. So we have an x. We're going to put that with x to the ninth times, we have 1y, that's to the 6th power. We have this 27 here, we'll actually put that in the front, times. And we have a z to the third, along with another z to the third. All right, so we still have some simplifying left to do. Negative stays the same. The 1 stays the same. 27 is by itself because there are no other coefficients to multiply the 27 by. Times x times x to the ninth becomes x to the 10th power. If you don't see an exponent, you consider that there's a 1 there, and we add our exponents, so 1 plus 9 is 10. There's only one y, and it's to the 6th power. Z to the third times z to the third, we add up the exponents to get z to the 6th. So our final answer will be negative 1 over 27 x to the 10th, y to the 6th, z to the 6th.